Hello students, we are discussing the topic pipelining in this video and subject is computer organization and architecture. So what is pipelining? Pipelining is the process of accumulating instruction from the processor through a pipeline. It allows storing and executing instructions in an orderly process, and this is known as pipelining processing. Means if we are allowing the instructions to be in pipeline and execute them using the processor, then this is known as basically pipelining processing. Pipelining is a technique where multiple instructions are overlapped during execution. What we can do in pipelining, we can overlap the different instructions during the execution of those instructions. Pipeline is divided into stages, and these stages are connected with one another to form a pipe-like structure. That's why it is known as pipelining or pipeline. Instructions enter from one end and exit from the another end. So these are the basic techniques. We can say how we can create the pipe for the different instructions while execution. Pipeline increase the overall instruction throughput. Why we are using the pipeline? To increase the throughput or performance regarding issues. Okay. Now, in pipeline system, each segment consists of an input register followed by the combinational circuit. The register is used to hold data, and combinational circuits perform the operation on it. So it is consisting of combinational circuit and registers. The output of combinational circuit is applied to the input register of the next segment. So stage by stage or segment by segment, we can create this kind of pipe for the various instructions. Pipeline system is like the modern day assembly line setup in factories. For example, in car manufacturing industry, huge assembly lines are set up, and at each point there are robotic arms to perform a certain task, and then the car moves on ahead to the next arm. So by using the pipelining instruction, we can use in different companies or factories too. And this is the block diagram for the pipeline. So this is the first segment, this is the register. So input of first segment, it is going to the output of the S1 is going to the R1, and likewise it is creating the whole pipeline, we can say, and finally we get the output. So this is the diagram. Now we have seen what is the pipeline and how it can be seen. So types of pipelines, it is divided into two categories, arithmetic pipeline and instruction pipeline. So in arithmetic pipeline are usually found in most of the computers. They are used for floating point operations, multiplications of fixed point numbers. For example, the input to the floating point addresses are x is equal, we can understand it by this example: a into 2 raised to power a y is equal to b into 2 raised to power b. Here A and B are the mantisas, significant digits of the floating point number, while A and B are the exponent. So these instructions can be, we can make the pipeline for execution of getting the result of this instruction. The floating point addition and subtraction is done in 4 parts. Compare the components, align the mantissa, add or subtract the mantissa, and produce the result. Registers are used for storing the intermediate results between the above operation. So in this way we can form a arithmetic pipeline. Okay. Now instruction pipeline. In this stream, the instructions can be executed by overlapping fetch, decode, execute phase of an instruction cycle. This type of technique is used to increase the throughput of the computer system. So of different instructions, the fetch, decode and execute phases we can overlap, and we get the better performance than the normal execution. An instruction pipeline reads instruction from the memory while previous instructions are being executed in other segments of pipeline. Thus we have execute multiple instructions simultaneously, means parallel, we are providing the parallelism in during the execution of multiple instructions. The pipeline will be more efficient if the instruction cycle is divided into segments of equal duration. So in this manner we can perform, we can make a instruction pipeline to increase the parallelism of execution of multiple instructions. So these are the types we can say. Now there are different conflicts regarding the pipeline, like timing variations, data hazards, mm, branching interrupts, and next one is this data dependency. So one by one we can see. First one is the timing variation. All stages cannot take same amount of time. This problem generally occurs in instruction processing, where different instructions have different operands required and thus different processing time. So timing variations can be the issue in pipeline processing. Data hazards. When several instructions are in partial execution, and if they reference same data, then problem arises. We must ensure that next instruction does not attempt to access data before the current instructions, because this will lead to the incorrect result. So this can be another problem. Now branching. In branching, in order to fetch and execute the next instruction, we must know what that instruction is. If the present instruction is a conditional branch and its result will lead up to the next instruction, then the next instruction may not be known until the current one is processed. So branching can be another issue. Interrupt. While processing interrupt, this may creates the problem. So this is another issue. Now next one is the data dependency. It arises when instruction depends upon the result of previous instruction, but this result is not yet available. So data dependency can be another problem. Next one is the advantages and disadvantages of pipeline. So advantages we can see, first advantage is the cycle time of the processor is reduced. It increases the throughput of the system. It makes the system reliable. So these three major we can say advantages we can have by using the pipeline. Disadvantages can also be there. The design of pipeline processor is complex and costly to manufacture. So cost and complexity are the issues with this pipeline processing. The instruction latency is more, so we have to add, or timing issues can be there. So these are the advantages and these are the disadvantages we can see. So what we have seen, what is pipeline, what are different types of pipelines, and what are the different conflicts during the pipeline processing. If you people are having any query, then ask me. Okay, thank you.